There is, to your point, research that we did on MP. I don't know if you are able to pull a tweet we did. One of our research interns, Joshua, I think it's a tweet on how we have 20% better quantized JLM52 than Nvidia. Essentially, what we found throughout like this 2-month research is, okay, quantization is a lossy. It's you're compressing the data from occupying 16 bits to occupying 4 bits, for instance, and so you're obviously losing some information, and you're trying to minimize that. And so when I say that I'm going to quantize the model, my job becomes, how do I find the layers that I can quantize and how to find the layers to not. For instance, with image models, I don't quantize modulation layers and I don't quantize out projections, because those two are like, out projection is what you see as the user, modulation is what the model sees or understands. Right, exactly. And so I guess to his paper, do you have I guess it doesn't have yeah. It's a long paper. I don't know if I can find.
If there's a part to search, or it's probably in the thread.
It's probably in the thread.
Yeah.
But basically, the long and the short is, it is very possible that quantizing more of the model makes the results. Like if I have a model that I quantize layers 1, 5, and 10, and another model where I only quantize layers 1 and 2. It is possible that the model in which I quantized more information is going to perform better because the quantization errors have canceled out. And so what Joshua showed in his mathematical proof, where he had like a verifier in, is that you can predict which layers are going to have quantization errors that will cancel out with each other, and you choose to quantize those layers. And so the result of doing this mathematical quantization is you end up with a model that's 20% more quantized than another provider. So you get 20% more throughput of it because there's more layers that running in NVFE4, and your quality is better than that other quant because the layers that you chose to quantize have their errors cancel out. Like one layer skewed to the right, one layer skewed to the left, one layer skewed to the right. Your final logits distribution is more similar to the original distribution of the model, so you have better fidelity. And so the way we proved this was with KL divergence. So instead of just scoring on the benchmarks, we scored the KL divergence between the logit distribution of the quantized model and the logit distribution of the original full precision model. And we showed that with this technique, we get